Hey guys, thanks for your attention. It's so grateful to be here. Today we are going to talk about Java deserialization attack. This year, my team, back to zero, we realized that there is a critical flaw in Java deserialization solution, including JEP 290 and header check, also ISP and so on. These defense solutions are widely used in famous application and company. So we spend a lot of time on research in order to uncover this risk in Java. Now we will share with you guys our thoughts and our research process and what we found during this research. In addition, we will discover two whole new attack vectors for Java deserialization, about new Gadget chain and some attack vectors. First, let me introduce our team. Back to zero, we founded this year with 4 core members. Our goal is to do some valuable research and share with security research to enhance the security level of the world. The BCM is an instant messenger, similar like WhatsApp, Signal, or Telegram. This product is born for the freedom of communication, a highly secure communication platform. Okay, my name is Zhang. I'm a founder of Back to Zero team, and also I'm a leader of security research department in BCM social group. I currently focus on application security, cloud security, and penetration testing. I also spoke at various conferences, such as Kansas West POC 09. Okay. Kunzhe also is a contributor of our research.
Okay, thanks guys. And my Chinese name is Kunzhe, and I know this is very difficult for you guys. And so I have English name is Anthony. And I have a team for research. I'm the founder of Pixar's team and Chief Information Security Officer in BCM Social Corp. And I also is author of the very famous realized attack tool name is MDK4. And maybe next part is for me. So next is Lucas. He will speak first, and I am the second.
Yeah. Here's the agenda. To start with, we will introduce some backgrounds of Java deserialization, such as some basic concepts. What is Java deserialization? What is it used for? And we will introduce a typical attack scenario. Then we will talk about well-known defense solutions for deserialization attack. Most of the company and famous applications will use this solution to mitigate this risk. After that, we will talk about a critical flaw in these solutions. According to it, we found two new attack vector for deserialization attack, which we use them to find a lot of Gadget chains. Finally, we will disclose two new exploits for Java deserialization, and we will detail in this presentation. In 2015, the Foxglove security team published a long blog. This article explains a real case of remote common execution by combining Java deserialization and some basic libraries, such as Apache Common Collections. A lot of Java web applications were affected, including WebLogic and WebSphere and Jenkins. It can be said that the Java deserialization vulnerability is the most serious security problem in the Java history. But nowadays, most of vulnerability Java has been banned by blacklist during the deserialization process. And there are some new solutions used to mitigate this risk. So it's hard to find a new gadget for deserialization attack. And we found a common thing in these solutions. which inspire us to conduct in-depth research in order to uncover the risk of well-known solutions and mitigate the risk of Java deserialization. Next, we will introduce the concept of Java deserialization. Be familiar with the concept. It could help you guys to understand the rest of the presentation. Okay. First, we need to understand the application scenarios of deserialization and serialization. In many cases, we need to transfer Java objects to a remote server or to another process. Because the object cannot be transmitted via the network, the sender needs to convert the Java object into bytecode first. The process is called serialization, converting a Java object into bytecode. When the server receives the bytecode, it will convert the bytecode into a Java object. This process is called deserialization. Eventually, we can call an object remotely by serializing and deserializing. We can look at this picture. An object can be serialized to bytecode and stored in database or local file or transfer it to network. In order to recreate the object, deserialization is an effective way. Just need to deserialize the bytecode and the object will be recreated. Java deserialization is mainly used in these following fields. The first one is the remote method invocation, just like RMI in Java. The second is transfer the object to the remote system via network. The last one is store the object in database or some local file for reusing. We all know that untrusted input data will easily lead to security problems. If we can control the input bytecode for deserialization, what kinds of security problem will cause? Next, we will introduce a common attack scenario. First, we have ability to control the input bytecode, and the class path of the application includes a serializable and vulnerable class. So the question is coming, how do you define a vulnerable class? We need to delve into detail of the Java deserialization process, and in this process, some predefined function will be called automatically. This function, which we call magic callback, for example, like read object or finalize. If there is a high-risk behavior in this magic callback, such as common execution or arbitrary file delete, that means we can call this high-risk behavior by Java deserialization. We prepare a demo, a vulnerability to help you understand this attack scenario. There is a vulnerable class in Apache Common File Upload.jar. It extends to serializable, means this class can be deserialized. If we deserialize this class, we will automatically call the read object function and eventually call the high-risk function named this.defaultFile.delete. Also, because we can control the bytecode, that means we can remove any file in the system. Until now, I'm sure you can more understand the concept of Java deserialization. Next, we will analyze well-known defense solution for Java deserialization. By doing this, flows of these defense solutions will be disclosed. According to these flows, we find two whole new attack vectors for deserialization attack. The first common defense strategy is to check the security of bytecode by setting a look-ahead check process. If a vulnerable class is detected, it will intercept and terminate the deserialization process. At the present, most of policies based on blacklist detection. The vulnerable classes will be written to the blacklist in advance. If the blacklisted class appears in the process, it will be terminated. Take a WebLogic as an example. If we input data to WebLogic server for this deserialization, magical callback resolve will be invoked. Then the resolve class will be invoked, which is rewrite by WebLogic. Finally, its blacklisted legacy function will compare the class name with the blacklist. If the class name is blacklisted, then the process will be terminated. The second widely used solution is JEP 290. This security feature was proposed in 2016. It's a new feature for Java 9 version. Whenever a deserialization operation is performed, the button layer will make a judgment based on the contents of the filter, so we can prevent malicious class from deserialization operation. In addition, you can limit the information of deserialization process, such as the length of the array, the length of the byte stream, the depth of the byte stream, and the numbers of the reference used. The filter returns several states of accept or reject. Currently, JEP 290 is also based on blacklist and whitelist. Oh, sorry. Here is a more widely used defense strategy named RASP. It's a security technology that is built or linked into application runtime environment. It's capable of controlling application execution and detecting or preventing real-time attacks. We often use Java Agent to do RASP. Java Agent is a software component that provides instrumentation capability to a Java application. It does not need to build lists like blacklist to match against the payloads, since they provide protection by design. Most of policies of RASP only focus on insecure deserialization attack, which try to execute commands using input data that has been provided by the network request. Next, until now, we have discussed three widely used Java deserialization security solutions. Have you found that all detection strategy mainly based on blacklist? The blacklist is exactly the least recommended security defense solution for security research. When we found a new vulnerable class, we need to update our policy to the blacklist. It will bypass our security policy. Of course, RASP relies less on the blacklist, but the current strategy also has certain security risks. When security research are analyzing the vulnerable class, they only focus on these common high-risk functions, such as the process builder, which can directly execute the commands. If we can find a fundamental function in JDK, and this function can cause security risk, such as remote command execution, what will happen? We are able to bypass most of security defense strategies. In a nutshell, our goal is to find a new vector in Java fundamental class, which can lead to remote command execution. If we find it, most of the defense strategy will be bypassed. Next, we will discuss two critical vectors. The first one is URL connection in Java. If you're familiar with Java, you must know the URL connection, which is widely used in Java. It's a basic class in Java. Most Java applications use it to send an HTTP request. Combine our goal we just mentioned, we conducted an in-depth study of URL connection. From the core graphic of the URL connection, we can find that it supports NTLM authentication. Finally, by calling JNI function to invoke a Windows API named initialize security context, which is a function to get local Windows credentials. If the URL connection can perform NTLM authentication automatically, then we can achieve our goal of RCE by relaying the NTLM hash to SMB servers. We found that the default behavior of URL connection don't judge the validity of URL, but always return true. It means that HTTP requests sent by Java will send NTLM hash automatically. We can relay the NTLM hash to SMB servers and achieve the goal of RCE. Unfortunately, Microsoft published several of patches for NTLM reflection attack, such as MS-08068, MS-16075, which can prevent SMB to SMB attack or HTTP to SMB attack. But we didn't stop to research this attack vector. Our team conducted an in-depth study of NTLM reflection attack. We spent a lot of time on NTLM protocol analyzing and fuzzing. Finally, we found a new technology to perform NTLM reflection attack. It can lead to RCE on latest Windows server. NTLM Manager is a suite of NTLM security protocols used for remote authentication, such as logging in remote SMB servers. Also, NTLM is a challenge response authentication mechanism supported by Windows, including V1, V2, and Session version. Also, NTLM authentication integrated by other protocols such as HTTP, SMB, LDAP, etc. The to SMB reflection attack is a representative attack in the history of NTLM reflection attack. Relay the NTLM hash to the same server. The local machine must authenticate itself successfully. Finally, it could lead to remote command execution. Microsoft mainly released two patches for this attack. The first one is MS-08068, which is for the SMB to SMB reflection attack. But this patch cannot prevent cross-protocol reflection attack, such as HTTP to SMB reflection attack. So the Microsoft released the second patch, MS-16075, to prevent HTTP to SMB reflection attack and enhance the security of NTLM authentication. Hot potato attack is a good example for HTTP to SMB reflection attack. Now, in order to achieve our goal of the goal of RCE, we need to exploit the NTLM hash and bypass the patches of Microsoft. We analyzing NTLM protocol. We found an interesting feature. There are some message flags in NTLM authentication. The document states that these flags will have more things in the NTLM authentication process, like negotiate sign. We can mark this flag to request server don't verify message signature. This flag will impact NTLM negotiation between client and the server. And also, some flags are security related. So we spend a lot of time on analyzing these flags and developed a tool to fuzz these flags. We found that there is a crucial flag named negotiate local call. The server set this flag to inform the client that the client and the server on the same machine. Does the flag affect the patch for NTLM reflection attack? Before we test the negotiate local call flag, we need to bypass the MIC protect. The MIC field ensures that NTLM messages are not tempered by attacker. However, our bypass allows attacker to remove the MIC protection and modify some fields in the NTLM authentication, such as sign negotiation. We discovered that our NTLM authentication requests are susceptible to relay attacks, no matter which protocol carries them. If the negotiation request includes a sign requirement, attacker would need to perform the following in order to overcome the protection of the MIC. So we can remove some special negotiation flags to bypass the MIC check. The following three flags that we will remove to bypass the MIC check. The first one is the NTLM SSP negotiate always sign, and the NTLM SSP negotiate sign, and the last one is the negotiate key exchange. This attack does not only allow attackers to overcome the session sign negotiation, but also leave the organizing vulnerable to much more complicated relay attack. Combine negotiate local call flag and the method of the job MIC. We can perform NTLM reflection attack successfully. So you can look at this picture. That way, modify some flags in NTLM authentication. Oh, sorry. And in this picture, you can find that we relay NTLM hash over HTTP protocol to local SMB servers on the same machine, and the authenticate successfully by modifying some flags we just mentioned. Finally, it will need to RCE impact. This is the first attack chain that we found for Java deserialization attack. Combine URL connection NTLM leaking vulnerabilities and the new technology for NTLM reflection attack. Eventually, we can achieve our goal of RCE. And in the later, we will show our demo for this attack chain. So now, I will invite my friend to detail the rest of the presentation.
Hello. Hi. Okay. Okay, this is my time, and I want to introduce some vulnerabilities in Java. And this is the second attack vector in JDBC attack. And we found there is a new attack surface in JDBC which will cause critical security problem, even lead to RCE. So the question is, what is JDBC? JDBC is a part of the Java standard edition platform. It contains a lot of APIs, and which we can use them to access a database and do some operation in database, such as updating data, modifying data, or inserting data. Additionally, we can use JDBC to access a variety of databases, such as MySQL, SQL Server, Postgres, and so on. In a nutshell, JDBC is very important in Java for different type of database accessing. And there is a sample of JDBC using by details the JDBC process in code. Will help you guys understand it better. And first, we need to define a JDBC driver name, such as which is common.mysql.jdbc.driver for MySQL driver. And we have written on this screen and import it to the Java class path. And then we can define a JDBC URL of the database that the JDBC driver will connect to. If the driver connects to the database successfully, and we can do a lot of things, such as executing circle in the database and inserting data into it. Because JDBC is a standard addition platform, we do not need to waste time on creating a personal connect driver. So it is widely used. Most of Java developers will use JDBC to operate the database. Okay, JDBC uses JDBC URL or URI to connect to a specific database, which mainly includes three parts: driver name, connection address, and extended parameters. And we can configure the driver name section to specify that JDBC uses a specific JDBC driver, such as MySQL driver, Postgres driver. JDBC connection address to connected remote database, including IP address point. And the last part is the parameter part. This is a part we need to focus on today, and it is a basic of the new JDBC attack surface. JDBC connection URI supports some additional properties, and which can be used to specify additional driver behavior. For example, adding SSL support and configuring SSL credentials and encasing Windows authentication capabilities. And this part can expand the capabilities of JDBC, can meanwhile introduce new security risk. By exploiting JDBC parameters, we will have the opportunity to let the JDBC perform high-risk operations. There is a parameter named auto-deserialize, which we want to discuss today. And it will enable the JDBC client to deserialize data automatically. Combined with deserialization vulnerability, we can achieve the goal of ICE. When the attacker receives the JDBC connection request, and he will return a malicious serialized bytecode payload to the victim. And finally, the victim will call getObject to deserialize the bytecode payload, which eventually results in remote command execution. By the default, the JDBC client does not call the getObject function to process server data. So we need to find a method to let the JDBC client process the data returned by the attack. Through in-depth research, we found that there is such as capability in the parameter expansion. Query interceptors, it will allow us to configure an interceptor and let this interceptor handle or return server data. Will there be an interceptor that calls getObject? How about it? Maybe the answer is yes. We found that there is a behavior of calling getObject in common point, MySQL points, CG point, JDBC, and this name is on the screen. And it can be found from the call graph that server starts diff interceptor will first call the post process to process all the data, and then the name is session starts value to to process the start data of the database server and use the result set to map to parse the data. And the result set to map eventually call to get object we need. And therefore, by combining the auto deserialized parameters and the query interceptors parameters, we will be able to let the JDBC client deserialize the server's data, and then use the deserialization vulnerability to finally call the ICE. So the above flow chart details this attack chain. First, the attacker sends the malicious JDBC URI to the victim. This long string is on the screen, okay? And the victim then connected to the attacker through this JDBC URI. When the attacker receives the JDBC connection request, and it will return a malicious serialized bytecode. This word is very difficult for me. Okay. And the JDBC client will use our specific server stats diff interceptor to pass the serialized bytecode, and will eventually call the get object function to perform the deserialization operation. Because we configure the auto deserialize parameters, get object will automatically deserialize, which will eventually cause ICE loophole. Oh, okay, and let's take a look at real-world attack scenarios, such as attack cloud servers, bypass SSIF defense, and phishing. Okay, first we can perform phishing attacks. Any client connect to our malicious servers will be attacked. We can put out network connection strings on GitHub, or we can perform social engineer attack. And the second, we can attack cloud servers. Many cloud servers provide an ability that custom can connect to their private database, and the server address is controlled by them. If we set up the IP address to the malicious server IP, cloud server will be attacked when it connected to us. And third, when we perform SSRF attack, most applications will be forbidden to connect to the intranet network, and it is illegal to fail in the public network. So we set a public network address, and we can ignore all SSIF defenses and gain ICE. And there are a large number of the scanners on the internet, and which scanning all the time in order to verify the vulnerability. Scanners will try to connect to the target servers, and if there is an attacker scanner connect to our server, and we can execute any command on this target. And this type of vulnerabilities can not only be exploited in many real-world attack scenarios, but also can be used as gadgets. So we can find the gadgets which can send a JDBC request. Anything will send a JDBC request to us will be affected. And when a client requests to us, we return the payload back and achieve the goal of ICE. Until now, we have detailed two attack chains in the Java. Both of them will lead to RCE. And combined with Java deserialization will expand the risk of Java. The first attack chain combines three vulnerabilities. The first is deserialization, and the second is anti-LM hash leaking vulnerability, and of URL connection and anti-LM reflection attack. We also can look the picture, which is the whole attack process. First, we need to find the deserialization vulnerability that can trigger a HTTP request. And then we can obtain anti-LM hash by exploiting CVE 2090-2426. And finally, we relay the anti-LM hash to victims SMB servers and lead to RCE. To demonstrate this attack chain and help you guys understand it better, and there is a demo video about this attack chain. Okay. Okay. And there is a Java web application Springboard running on Windows Server with patch installed. And then we run our NTLM reflection attack tool and listen log point by using Metasploit. Yeah. And we found that web application will deserialize the file upload by user. So we upload our POC, which will trigger the server send the HTTP request to us. When our NTLM reflection attack tool receives the HTTP request, and we can obtain the NTLM hash by exploiting URL connection vulnerability and relay it to SMB service. Finally, we successfully execute our backdoor on the target. Let's summary. So we realized two new attack chains in Java. And the first one combined two vulnerabilities, CVE 2090-2426 and CVE 2090-1040. The second one is exploiting JDBC by using them can easily to find new gadgets for deserialization attack and extended the impact of deserialization attack. And in next range, we will realize several gadgets we found, including for deserialization attack and or some like a JSON attack. In first jar, we want to discuss is common JX path. It can be found through the call in the call graph that a magic callback read object will eventually call the URL point OpenStream function. And the URL OpenStream will leak the NTLM hash, and we can use NTLM to the SMB server and eventually cause remote command execution. And the second is Kunzhe. In the past, we also used Jar for deserialization, but all vulnerabilities of them have been patched. And combine our new attack chain, we can easily find the new gadgets and lead to RCE from the call graph. So we can find that it will invoke OpenStream function finally. So we can exploit it and gain RCE. Combined with our new attack vectors, and we can find many chains in short time. Some of them are also very simple, such as HTML parser, and there are only 2 steps in the call chain, so which is very easy to find. Our attack vectors not only provide a new gadget chain, but also extend the impact of JSON attack. And JSON ARMA shell is widely used in Java application, combined with our new attack vectors, and we can find many new gadgets and bypass most of blacklist. And JSON attack combined with JDBC attack vectors can also easily cause RCE impact. We mainly introduced 2 attack chains in this presentation. And the first one is the URL connection and the new technology for NTLM reflection attack. And combine these 2 vulnerabilities, it will lead to RCE. And the second one is the new attack surface of JDBC. And the parameters of JDBC will extend the ability of JDBC. Also will increase the risk of JDBC. So we just detail the concept of vulnerabilities and exploiting method. And last, we will talk some several of Gadget's chain for deserialization and JSON attack. Okay, at last we have some recommendation for you guys. And if you can guarantee the security of deserialization and the success that do not deserialize any untrusted data. And do not send HTTP to any untrusted data, and do not send HTTP request to an untrusted server, and if the client is on the Windows. And do not connect to untrusted database by JDBC. And careful audit security policy when using blacklist. Try to use whitelist to mitigate risk. And fuzz your application with these two vectors. It's easy to find these two types of vulnerabilities. And static analyze can easily to find some JDBC vulnerabilities, and keep your Windows server with the latest patch installed. Until now, we have detailed to attack chain in Java. Both of them will lead to RCE. Combined with Java deserialization will expand the risk of Java. So this is a question and answer. Does anybody have some question? If you are very interested for this talk, or interested for some JDBC, for for even if you are very interested for me, or for this talk, okay, you can answer me.
Hi. Sorry, right here.
Oh, no. Okay. So where are you?
Back here.
Oh, okay.
How prevalent did you find that the attacker being able to control the JDBC URL is actually in like real-world deployed code? Did you see that frequently? Because to me it sounds like, you know, having, especially for like an unauthenticated attacker, it sounds like having control over a JDBC URL would be not that common. But did you guys find that it was the case for a wide array of products?
Okay. You know, we can't speak English very well, so please replay it and slowly. Okay.
No problem.
Okay.
How common did you find that an attacker could control the JDBC URL in a particular product?
Okay, I got you. Oh. Okay, maybe I got you. When you using the cloud platform, she will provide the ability to connect to your database. So at this moment, you can fill your JDBC URI to the cloud platform, and the cloud platform will connect your JDBC URI to your database. So at this scenario, you can modify the JDBC URL to your JDBC URL, and your database may be a malicious database. So at this case, you can return some payload from your database to the cloud platform. And for the Java deserialization, you can control the bytecode of the for the deserialization. So you can modify the JDBC URL in the deserialization process. Okay.
So other than, for example, with cloud providers, did you look at any sort of standalone products that, you know, accidentally allow control of the URL by an attacker?
Yeah. Actually, we have tested some cloud platform, but just in China, some Chinese platform. You know that maybe this vulnerability I can't disclose to you guys. It's classified. Sorry.
Okay, thank you.
You're welcome. So, anybody have any questions? Okay. Maybe.
Hi. Can you please explain a little bit more how did you produce the Java serialized payload and the HTML reflection? Any GitHub open source tool, custom-made tools? How do you do it?
About NTLM reflection attack.
Yes, both the payload, the new serialized malicious Java payload, and the reflection.
Sorry.
How did you produce it?
Can you speak slowly?
Yes.
I can't get you, sorry.
As far as I understood, there are two steps involved in the exploitation. Yes.
Okay.
Exactly. The previous.
This one?
The left one is the new payload where you curl a malicious Java object.
Java.
No, the page with the screens, for example, where
This
you
one?
have the interpreter,
Okay.
the reflection, and the curl command.
Okay.
In the curl command, you posted a malicious Java bytecode, right?
Maybe I got you.
In the POC. In the POC page, where you had the interpreter,
Oh,
the reflection attack, and the curl you posted.
reflector? Sorry.
The page you had the interpreter, go there.
Uh-huh. So. Oh, demo. Okay.
The demo,
Got
yes.
it.
Yes.
So sorry.
Nice, there. In the left screen, we had the curl.
Okay.
Okay. In the curl, you posted a malicious Java bytecode, right?
Yeah.
How did you produce this? With custom tools? You developed for the serialization,
Yeah.
like why so serial, for example.
Yeah.
How did you do it?
Maybe I can introduce the whole attack process to you. The first step, we need to find the application that we can control the input bytecode for the deserialization. Okay. The first one we need is the deserialization vulnerability. Okay. And the second one, we need to find a gadget that it can trigger a HTTP request to us, maybe to an attacker. Because we need to HTTP sent by Java, that we can get the NTLM hash automatically. You know that it's about the first CVE, about URL connection. That will leak in the NTLM hash to the attacker. Okay. The second one is the NTLM reflection attack. That we discover in this year, CVE 2019 and 1040. Okay, this vulnerability, it will modify some flags to bypass the MIC protect, and there is another flag named negotiate local call. We can change the flag of the local call to the 0. That means the client and the server are on the same machine. Okay, so we can use this method to bypass the MIC protection and perform the NTLM reflection attack. Okay.
Have you write a public form for that? Is there any public form for that?
Maybe in next year we will publish our tools or article to you guys. Okay. You are welcome. Hi.
Hi there, thank you. Are you planning to publish your gadgets or put them into Wiser Serial in the public repository?
Okay. In this presentation, our main thought is to discuss our thoughts about the risk of Java. We can, according to our method, to find a lot of Java gadget chain. That in this presentation, we discuss some gadgets chain that we found in a short time. In 1 hour, we found a lot of chain for the Java deserialization and the JSON attack. So it's a basic concept of the risk. So we can, according to it, to find a lot of chain. Okay, and about the tool or more detailed article, we will maybe publish next year, maybe next year, yeah. Oh.
Hi. Yeah, I just have a quick question about the gadget chains. I would like to know how you search for new gadget chains. Are you using some tool like Gadget Inspector, LGTM, or manually?
Okay, got you. Do you know a conference named PhD in Russia? Okay, in this year we have a talk about our Java vulnerability platform. We can use our platform to find lots of gadget chains and some vulnerabilities in Java. You can search it, search the PhDs on the Google, so you can find our platform for the Java vulnerability discover. Okay, and we don't plan to disclose our platform in this year. Maybe we can consider it in next year. Okay. Okay, thank you. Okay, thank you guys.